thank you very much. I'm particularly pleased to see so many good friends and colleagues of many, many years. I won't say decades because that sounds like we're older than we really are. Yes, it works. Samarsh. And thanks to Don Conway for introducing me. What I'm going to talk about is what we're really calling transdisciplinary science for a sustainable future Earth. It's an initiative of the International Council for Science and many other organizations. And so I want to just quickly go into it. But I want to start off with, though, is to give the kind of perspective that I think hopefully will appeal to politicians and general people rather than us dedicated science guys. So I will quote from the World Economic Forum. This report came out in 2017 in January. And what they do is they look at global risks of an uncertain nature or condition that, if it occurs, can cause significant negative impact for several countries or industries within the next 10 years. So not decades away, but 1 decade away. And so they rank things by impact, high impact at the top of risks, and likelihood. So the ones of real concern are in the upper right corner. So what is the first one of concern? Actually, extreme weather events. Natural disasters, failure to take action on climate change mitigation and adaptation, and down in there, human-made environmental disasters. These are the issues that economists looking at it through the World Economic Forum and Davos and others made their assessment. I was not part of this. There are also others, of course. They call those were the environmental issues on the top, but these are what they call societal issues, water crises, spread of infectious diseases, food crises, large-scale involuntary migration. I should say the one of highest impact in the upper corner right here is actually nuclear war. They fortunately consider it of low likelihood but high impact if it happens. That was before Trump. So, anyway, interestingly, they also include a whole series of issues which I collectively call governance issues, and I'll come back to that in a minute. So these issues, when you look at them, are very much, when you start thinking about them, they're interconnected. For example, extreme weather events will cause water crises such as droughts and floods. The impact of weather and failure to take climate change adaptation could lead to food crises, spread of diseases, and migration. Much of involuntary migration is caused by political issues, but also other parts of it are caused by droughts or floods or damage in countries, so that people are migrating, not because they wanted to, but because they have to get away from all of this. So these are intersecting issues. And there's geopolitical issues, as I said, the governance issues, technological issues. Interestingly, they have very few. This one is on basically data theft and things. They also have failure of critical infrastructure as one of the major economic issues. It's right in here. It's not that high on the list, but it's one of the few blue circles. And when you look at it, one of the major issues of failure of critical infrastructure, again, is windstorms, floods, etc., affecting buildings, property, infrastructure, homes, etc. So these are the issues. And what it really points out to me is the relationships between governments and society, but the economic risk and the relations between hazards, climate, poverty, health, economy, and other issues. And we really need to work together, have the actions to reduce these risks and develop the capacity so that, as we say, no one, whether it's in developing countries or less poorer regions of our country, that we give them the capacity, the support, so they are not, quote, left behind. And we need to have what I call integrated transdisciplinary science programs integrated across all levels of government and involving also the academic side, private sector, and coordinated with global science programs. I know this coordinated looks to be spelled wrong, but we won't catch that one until the next time. They went through, and they also, in this same report, they produced what they call global risk connections. They're looking through these various lines back and forth at what things are connected. And I want to go through this just quickly, just to say that if you look at all the lines connecting in here, these things are all interconnected. And they're interconnected also with these issues of governance, urban planning, or failure to urban plan, failure of governments to take action at the national, regional, and global level. So we really get down to the case again of sciences in that broad sense of the word, environmental science, natural and social, which is where I come from, but also geopolitical, political science, economics, engineering, health, you name it. These all have to be brought together. So, just to say, natural disasters, as we said, extreme weather events. This is some data from one of the insurance companies, Munich Re, up to 2015. And what we see is an increasing number of climate change-related events. These are meteorological events, floods and storms. Storms, these are floods, these are hot days. The number of geophysical earthquakes is continuing, and they're very horrific when they happen, but fortunately, they're not increasing in numbers. And this is one of the many evidences in, for example, the issues of climate change that we talk about. So one of the things we have to do when we deal with extreme events is look at it from the Canadian perspective as well. We see these are just the examples of the various things, including the Fort McMurray fire, the Alberta and Toronto floods, the Eastern Canada ice storm. I don't have it on this diagram, or in this presentation, but since somebody mentioned children, how many of you were here in Montreal in 1998? Eastern Canada ice storm. Montreal was closed down. I have to admit, I was head of the weather service then. We actually forecasted very well, but unfortunately that didn't help because the tragedy happened. Montreal was closed down. But how many people are aware that in 2008 or 9 that the Montreal Neurological Research Institute produced a report? And in that report, they reported that the children who were in their mother's womb during that stress period, and at that point 6, 7, 8 years of age when they tested them, were both physically and mentally handicapped because of the stress that their mothers went through while they were pregnant during that 2-3 month stress period when they didn't know if they'd have any electric power. They didn't know if their jobs would be saved. They didn't know that. And what we're seeing is that, and this was also documented in the Calgary flood, that people were traumatized by this. So this is another dimension that we never think about. We count dollar amounts by saying, well, so many buildings were wiped out, that's worth $5 billion. Well, that's pretty horrific. But that's the other reality is that the effects on people, the trauma they face, the loss of livelihoods and these things really account to a lot. And we need to keep that in part of our thinking. So when we look at it, we just recently, I pulled this down. This is the latest tornado we just had recently. And you might have heard about it. It was in the news. And so what do Canadians do? Well, hopefully, when they hear the warning from Environment Canada, or whatever way they get it, they take cover. But not all of them. Some of them go out and mow their lawn. And it relates to this is where we get into this issue of all the sciences related to the needs to address the issues of disaster risk management. What we call risk interpretation to action. When people and or governments receive information on impending threats like tornadoes, hurricanes, droughts, etc., what do? Do they take action, the right actions, or do they take the wrong actions? Like guys who go out and mow their lawn. It's difficult. You've probably heard of I'm sure, the Fukushima, the huge earthquake and tsunami. And I was there not long after. I've been through the site as things were opening up and seeing the horrific damage still after years in some cases. But what you heard from some of the Japanese scientists who are following it, the Japanese Meteorological Agency, I emphasize it was the Weather Service who put out the warning on the tsunami. And in one school, the teachers had training on what to do when you hear a tsunami warning. They did it right away, and in that school, every child survived. A school not far away, the teachers had no training. So they do what managers do. They convened a meeting to discuss what should we do now that we've got this warning. And the tragedy is that apparently 70 or 80% of the kids in that school died as a result of this lack of understanding of what we do when we get the warning. So what I'm saying is, how do we take the action? Why do they do it? What actions do governments take? Did you know that in Canada, if your government doesn't do anything to prevent you from being flooded, you can't sue them? But if the only thing you can sue them for if they fail to dig you out to pull you out of the water after you've almost drowned. But they're not required. You can't sue them under ethics or liability if they don't take action to restrain you from building that nice house right along that river, which is in the flood zone. And Jim Bruce developed all these flood rules and things, and that, largely speaking, unfortunately, they're not enforced. So anyway, I won't go too much on it, but I just had to end with, I was looking for this picture, and up came this cartoon. And if you recognize that face in the background there, this is one of the issues we're facing with. People who pay no attention to science will walk away from anything that involves things and blow up a tornado. Anyway, on to the next thing. Impact from hazards, though, importantly, they do depend on the flood, storm, drought. They very importantly depend on the vulnerability. Are people vulnerable? Are they poor, impoverished, etc.? Or are they exposed? And exposure and vulnerability are major factors in causing the determinants of disaster risk. I had a research project just finished last year working with people in the Philippines, Manila. And this is one of the rivers in Manila. There are an estimated 1 million or 2 people living along the river basin who were basically evicted from their property where they had moved in from the countryside. The city decided, no, we got to have a shopping mall there, so get out. And they live in basically cardboard boxes or worse along this river basin. And the Philippines is the country that has most disasters per year of any country in the world, many floods. They have 22 documented disasters per year on average. And those people are drowning because they're both poor and they're very exposed, obviously, to floods. So let me just say we got to do this. There is the issues of the relationship, as I say, between disaster risk, climate change, poverty, development. And these are linked issues with the Sustainable Development Goals. So anyway, moving right along, we have all these issues as policymakers, government, scientists, community we need to address, and this is just a collection of them. I probably left out a few. Important thing, in 2015, we had what we call the policy agenda. In March 2015 was the Sendai Framework on Disaster Risk Reduction. How many people before this talk had ever heard of the word Sendai Framework? I'm not surprised that many of you haven't. It's hardly ever in the news, but it's very important in my opinion. We have the Sustainable Development Goals you've probably heard of, and we have the Paris Agreement, which everyone's heard of. But they all three together, in my opinion, need to be brought together and linked in an integrated way to see the future. And so when we talk about seeing the future, sustainable development basically says we got to make ability to make development sustainable to ensure it meets the needs of the present without compromising the ability of the future generations to meet their own needs. That means we got to be able to see ahead. That means we need to bring in the sciences, the technology, the economy, but also issues of economy again, but society, movement, migration, all kinds of social issues, and link these in ways that we sort of go ahead and go back and see how these things change with time and what actions we can take. So it needs an integration across the natural and social sciences, health and engineering, of course, as well. So we need to have, as we call, evidence-based decision-making, including the understanding of how societies work and function, and how will they respond when they get the information that, I'm sorry, but you're living in a floodplain. You should really not live there. But I own this property and I want to sell it because it's worth $1.2 million now. House next to me, across the street where I live in London, Ontario, just set a new standard for our street. It sold for $1.1 million last week. And I think, God, I suppose it's personally good for me, but what does it affect on societies, on mobility, on people moving and living? Anyway, so Sendai Framework for Action, just very quickly. This is the meeting was held in Sendai, actually it was held in Sendai, Japan in March 2015. And as was noted, I'm the president of the International Council for Science, so we are usually the lead for what we call the Science and Technology Major Group in the UN negotiations. So that is me. I don't know who took the picture, but someone sent it to me. Sitting up at the front, I get 3 minutes of time in an hour or two. But anyway, you're there, and we can mobilize the science community to push these things. And we came up with, I think, some pretty good objectives scientifically. Understanding disaster risk, strengthening disaster risk governance, investing in disaster risk reduction for resilience, and learning to build back better. So when your house is flooded out, you don't, when the flood goes away, build it back exactly the way it was. You build it back differently, better, or maybe not at all, but build it somewhere else. And so these issues are wings that we're trying to build science programs to address. Sustainable Development Goals. I'm sorry, how many people know how many SDGs there are? Okay.
17.
Right, 17. Okay, how many goals are there? Targets.
I have no idea.
34.
No, keep going.
169?
Right, exactly. Points to the guy at the back there. Because there are 17 Sustainable Development Goals, 169 targets. Now, I had the privilege, in a sense, as representing the science community, to participate in some of these negotiations. I found it both interesting, but, for example, in Geneva, in this process, we could speak in the morning and the early afternoon. At 2 o'clock and onward, we were allowed to observe, but as non-governmental people, we're not allowed to say anything. Well, not officially. And I sat there until close to midnight, and they were still arguing over one paragraph or 2 sentences, back and forth, back and forth. I went home at, by midnight. At the next morning when they reconvened, I was told they actually accomplished 2 paragraphs overnight. And it was all a debate over wording of details. And that's where you got to 169 targets. So, but here they are. Here's some of the targets, the goals. And they are important. Poverty, hunger, healthy lives, gender equality, water, sanitation, energy issues, sustainable growth. And these things are interlinked. You can't have healthy lives if you're all poor and you don't have any food, that kind of thing. So these are linked. Issues of water feeds back to, if you don't have healthy water, you don't have healthy lives either. Issues of energy and water, etc. And there's some of the next ones. Issues of, for example, sustainable infrastructure, inequality, issues of ocean and climate change, acidification. Ocean acidification is indirectly talked about, some of these things, land degradation. And what we as the science community focus on, in addition to solving these, number 17 says, strengthen the means of implementation and revitalize the global partnership for sustainable development. So we're building research programs, which I'll talk about in a minute, to try and build that strength so we have the science capacity to address this. So we also, though, do and get involved as the science community. The International Council for Science and the International Social Science Council brought together about 30 really top, maybe 10, 12 really top scientists and said, can you go through these 17 goals and 169 targets and give us an assessment to be helpful, not to be critical, be helpful. And the assessment was that of the targets, these 169 of them, that 29% were well-defined based on good evidence, 54% need more work, and 17% were weak, non-essential, and probably better to get rid of. So they made some recommendations, and to summarize, the overall recommendation is that for this very large number of issues, we need to have a overarching goal and really focus on 6 essential elements. Issues to do with, I can't hardly read it from here, dignity, people, planet, partnership, justice, and prosperity. But anyway, bring them together in some way that we can focus on what it is we want to get out of this. So we're working with the UN agencies and others on this. Climate Convention, you've all heard about. It focuses on mitigation, but also importantly, adaptation. And for some of us who had jobs in the government as an ADM, my responsibility in part-time was adaptation. But it's largely lost in the system still. And adaptation basically means adapting to the reality is that under all the good climate scientists says, if we were to even reduce our emissions to 0 tomorrow, we would still have warming for the next 20, 30 years. We're going to have more hot days, more heavy wind events. We got to adapt to it to reduce our impact, and where there are some, and there are not many, but there are some, take advantage of those opportunities. So, some of the things we have to look at, the climate projections for the future, in case you're not aware, when they talk about 2 degrees C warming, they don't mean 2 degrees C from now. They mean 2 degrees C from 1850, because that's the start of the Industrial Revolution when the emissions started going up. So what you see is 2 degrees C on that target is there. And, well, it actually should be up. I guess this PowerPoint got moved a bit. Anyway, the point is that when we look at these things, we have natural climate uncertainties, this uncertainty here for a given emission scenario, but we also what I might call, which we need to reduce that uncertainty so the deniers aren't using that to say, well, you guys don't even know what it is. We do know well enough the climate change for a scenario. But the reality is the human, what I call human climate science, the difference between this scenario and that scenario is huge. And that's the choice of what humans and governments, societal choices, as I said, want to do between these different things, these various RCPs, and so on. So we have huge social, societal issues there. I'll just say there are other issues to do with warnings and systems, and there's where we need to get support on decision makers. We need to help the developing countries. And there is an attempt now in Canada to develop national adaptation plans across the provinces. It hasn't gone very far yet, but they actually hold meetings. I attended one of them. But the issues are, when we get an early warning system, how will be the information provided by who? Does it come from your local radio station, which may or may not be relying on the best sources, i.e. Environment Canada, I'm biased, of course, or somewhere like that, or somewhere else? How is it interpreted? Do you go out and mow the lawn, or do you actually do something to reduce your impact, being impact, etc.? The decisions are making by whom? More floods, the living landscape, changing dimensions, cultural heritage. All these are social, societal issues that we need to work together to reduce the impacts of flooding, knowing they're going to happen, but when and where and how and who will be impacted. So let's work on that. I mentioned adaptation. I don't know how many people know who John Godfrey is. John Godfrey was a member of Parliament, actually a cabinet minister under Paul Martin. He's actually now, according to this document, and I know what it is, he is the senior special advisor on climate change to the government of Ontario. And John and I are working together. We held a workshop recently with he and some others on the issue of climate change adaptation. How do we get governments to take advantage? And he pointed out this article which he'd written, which he hadn't sent me before. But anyway, I'm just summarizing a few words out of it. In climate change, we need to do with mitigation, which is emission reductions, but adaptation, economic opportunities. And unfortunately, as he summarized it in words, it does not lend itself easily to the traditional models of ministerial responsibility in governments like Canada. You get to climate change at the federal level. You say water. Well, who's responsible for water? Well, it's NRCan, it's Environment Canada, but the provinces say it's their responsibility. In Ontario, where I live, I guess you guys, most of you live in Ontario, who does the flood forecasting? It's done by the Toronto Regional Conservation Authority, near where I live, or the Thames Valley one. It was done by the province or at a lower level of responsibility. And municipal governments make the choice of where you can zone things. So you can build in the floodplain, it's okay, because if you build there, we'll get more property taxes because that's seen to be expensive property because it's along a river basin, hence high value, at least until it floods. And what he says is we require a whole level of governments. We need to work together. Adaptation, he says, is extracting, or at worst, immoral. I didn't quite necessarily that word, but some people argue if we're going to say we have to adapt, that means we're giving up on mitigation. So we don't want to talk about that. And that's silly politics, but that's unfortunately reality. So I'm just saying is that these things, and John's conclusion is we need to have this as a central agency. It's Treasury Board, Finance, or in the Cabinet Office. Anyway, having discussed unfortunate politics, I'll go back to international science. I just want to do one moment of bragging, or at least explaining. The International Council for Science, that I happen to be the president of, is an international organization created in 1931. If I remember right, yes, 1931. We presently have 122 national members. These are usually, like in the U.S., the National Academy of Sciences, Royal Society of London, the Japan Science Council, South African Academy, Indian Academy of Sciences, etc. 122 of them are actually, there's more of them because the Caribbean group come in as one member, but it's all the Caribbean academies. In Canada, for traditional reasons, it's the National Research Council, and that's fine. We also have 31 unions of scientists by discipline, including the one that deals with mostly the climate and weather stuff, the International Union of Geodesy and Geophysics. But there are 31. But they include math, physics, chemistry, biology, radio science, brain stuff, but also psychology, sociology, cartography, geography. Anyway, 31 unions of scientists by discipline are members, and we weight them. When they vote, the union votes, being 31, is roughly 1/4 of the number of national members. So when they vote on issues of electing their officers, the union votes are multiplied by 4, roughly, so that their sum of their votes is equal to the national member votes. The idea is to have the disciplines, the scientists represented equally with the national members who actually pay most of the dues. But anyway, and the mission of the International Council for Science is to strengthen international science for the benefit of society. I emphasize for all societies. Its a vision is where the excellence in science, all sciences, is effectively translated into policymaking and socioeconomic development. We work in several areas. We try and work on issues of data and information, openness, quality, etc., accessibility, scientific capacity, building capacity in Africa, South Asia, and other developing areas of the planet. And we focus on 3 priority areas: the universality of science, as we call it, the freedom to do, and the responsibility in doing science. Freedom, in this case, is the freedom of scientists, for example, to attend scientific meetings. When the Trump put in his first migration bill, there were 15 Canadian university scientists who happened to be from other countries sitting at an airport in San Francisco, not being allowed off the airplane to attend a conference on physics, because they said these guys were mostly actually from Iran, and there's no, you can't, not allowed in. Now we argue, and we put up on our website and put in letters to the media right away saying this is unacceptable from the point of view of international science, the freedom and the ability and the necessity of working together for science. Also worry about the responsibility of scientists. And this is unfortunately becoming a bigger issue. I was at the World Conference on Scientific Integrity a couple of years ago, and I spent my time, not having attended one of those meetings before. I should look at the time, how much I got left. But anyway, my wife is smiling now. You want to stand up because you're the good-looking. Anyway, at the World Conference on Research Integrity, I gave one of the presentations early in the program on quite frankly climate change deniers. Are these people credible scientists? What kind of nonsense are they presenting? But anyway. But then they went on, and they were talking mostly actually about the pharmaceutical science industry, but I think this actually applies in some other areas. There were certain scientists who actually created, one guy, they put his picture up on the screen, he created 4 scientists with websites, CVs, pictures, who didn't actually exist. He would submit papers to journals, suggest these people as referees. The articles would go to this website. He would get it. He would send back glowing reviews. And, my God, papers were published. And how this was discovered, I don't know. But all I know is that, unfortunately, the evidence is increasing. There's more of this happening. And that was an extreme case. But nonetheless, it is a case. So we work on that issue. We have a committee on this that will put out statements, do investigations. When scientists in, one recent case in Turkey again their union association was being, let's say, affected by the government, we write letters. I'm not sure we always have effect, but nonetheless we try and do something. We also worry about science for policy and policy for science. I'll come back to that. And we also worry, in a big area, is what we call international research collaboration. And that's what I'm going to talk about quickly. And this is the present executive board of the Council of Science. That funny-looking guy in the middle is me. But the past president is Y.T. Lee, who is a Nobel Prize-winning chemist, and he's from Taiwan. He won the Nobel Prize in chemistry when he was at the University of California, Berkeley. And he was then, when he was elected, he was the president of the, we have among our 120-some members, national members, we have the Chinese Academy of Sciences, located in Taipei, and the Chinese Academy of Sciences, located in Beijing. They sit beside each other at the table. And usually, it's not a problem. This guy is our past president. Up here is the vice president for policy and review, Jinghai Li, who is from the Chinese Academy of Sciences in Beijing, actually vice president of the Chinese Academy of Sciences in Beijing. This young lady is the rector of the University of Pretoria in South Africa. He's from Australia, he's from Poland, he's from the US, he's from India, he's from Japan, Australia, France, England, Turkey, Spain, etc. We try and get a global membership. We have, and so among the programs we've created over the years, jointly usually with international UN agencies, for example, the World Climate Research Program is co-sponsored by the Council of Science, the World Meteorological Organization, the Oceanographic Commission of UNESCO. It was created in 1980 to determine the predictability of climate and determine the effects of human activities in climate. And this organization has been, with other partners, among the leading sources of the science for the Intergovernmental Panel on Climate Change Assessments. And how many people know who created the Intergovernmental Panel on Climate Change? Right there, that guy, Jim Bruce. He convened the meeting in Geneva in 1988 to create the Intergovernmental Panel on Climate Change. Thank you, Jim. Wow. And that process has been basically the source of information on which the UN Climate Convention's decisions are made. And that process is really highly scientific. I've been an editor, a lead author of chapters, and let's say I've published many papers in my life, but I've never gone through the review process, the editing, the revisions, the editing, the review again. 3 times we go through reviews before you get a paper out for the IPCC. But anyway, thank you, Jim. What they're looking at is, among other things, the emissions and their relationships to temperature and climate. The World Weather Research Program we're not part of this, but looking at extreme weather events. How do we get them? How do you get them out as forecasts? A program that we've created more recently is this one, looking at integrated research on disaster risk. And this program is an integrated across the disciplines, natural, health, engineering, social sciences, as an international research program. Its project office actually is in Beijing, China. And it looks at issues like hazards, vulnerability, and risk. And it looks at the issue of, as I mentioned earlier, risk interpretation to action. How is decision-making made? How do people interpret risk? We've got psychologists, sociologists as part of this research team. And we've created what are called international centers of excellence for this. There are 12 of them now. Just a couple of them I'll show you for examples. There's one at King's College London on risk interpretation. There's one called Disaster Resilient Homes, Buildings and Public Infrastructure. And that's the Institute for Catastrophic Loss Reduction at Western University that I'm part of. And we work, mostly the people who do all that work are wind engineering program people, geophysicists looking at earthquakes and things. And if you go on the ICLR website, you can get for your own home ways in which you can reduce the risk of flooding damage, water, etc., that kind of thing. And I just want to say is that Don Fejeron, the president of the Insurance Bureau of Canada, has actually said the government is actually getting it right, starting to anyway, because we had record costs to the insurance sectors, $1.4 billion in the flooding in 2013. What he's saying, and I underline this, is the shift from a culture of disaster recovery. In other words, when we have a flood, you try and figure out how to fix up after it, to a culture of disaster risk reduction. So how do we, knowing there will be floods, how do we get it so the flood happens, but there's not a disaster? There doesn't need to be a disaster just because we have a flood. So we have another new program, Pierre Ritchie. Anyone know Pierre Ritchie at University of Ottawa? Psychology professor. I know he told me he couldn't be here today. So anyway, he's been the chair of the science committee in a new program we just started on urban health and well-being. Oops. And Pierre Ritchie's this guy here in the picture. And they're actually also set up in China, in Xiamen, But the idea here is to look at the issues of health in urban environments in various types around the world. And this program is just starting. The big program I want to mention particularly is called Future Earth, Research for Global Sustainability. And what we're trying to do is provide the knowledge for the societies to face the risks posed by global environmental change and seize the opportunities in the transition to global sustainability. In other words, how do we properly address the SDGs and, in fact, the Climate Convention and others? So it has a governing council, which is UN agencies, but also the International Council for Science. And right now I happen to co-chair the governing council with the rector of United Nations University in Bonn. And we work very closely together. I'll be Skyping him again tomorrow, as we do at least once a week. We have an executive secretary, an advisory committee. And interestingly, we have program offices rather than one, as we have in other places. We have now 5 international program offices, each funded by national members. The one in Montreal is actually funded entirely by the Gouvernement de Quebec, through Remy Crillon. One in Paris, one in Stockholm, one in Colorado, and one in Tokyo. And we are trying to do it differently than we knew science. Usually we set up a science committee and we say, we got 2 years, you guys, come up with a science plan. And then we do the science for 5 to 10 years. And then we go back to the public and we say, here's what we've done. Now what we're trying to do is work with the communities, the stakeholder community, to co-design it. So we've established an advisory committee mechanism that involves scientists, but also stakeholders, business people, community managers, environmental groups of people who can bring in that dimension of what is it we should be doing, and working together with the scientists to better define the scientific objectives and projects. And so we then work to co-produce the results, co-deliver it to communities, and keep an iterative process going through this decades of science together. And so this is an integrative process, and we want to have, as we say, how can we involve the best scientists, involve society best, to find the approaches that will give us the right future. And I would like to announce officially today, this is hot on the press, maybe an hour ahead of when I'm supposed to be announcing it, but anyway, I'll let you guys know about it. Today, Amy Lewers will be the new executive director of Future Earth. She will move to Montreal this summer. Amy is a brilliant, younger than me lady. She is presently the director of the climate and water part of the Skoll Global Threats Fund at Stanford University. She spent 2 years in the White House supporting President Obama as the advisor on environmental and water issues. And before that, she was actually worked for several years for Google and trying to put in environmental issues into the Google framework. Before that, she worked in Latin America in developing countries to help people right on the ground in communities better respond to environmental issues. She's a PhD from Stanford University. And Amy, I'm pleased to say, accepted 2 days ago, and the press announcement is supposed to come out about now, but I'm not totally sure it has, so don't talk about it until later today, please. Anyway, Amy will be taking up this position, and she'll move to Montreal in the summer, because Quebec, I'm trying to get the feds to put in some money into this. So far, I don't have a nickel out of them, but I've got Remy Crillon from Quebec is putting up the money. Anyway, what is Future Earth? What we're doing is building what we call knowledge action networks as mechanisms to work together. And we've, for example, focused on water, food, energy together, issues of oceans, transformations. How do we transform societies to reduce emissions, for example? How do we deal with the sustainable development goals? These are not, let's say, not exclusive in the sense they're overlapping, but the understanding is create groups of scientists to work on them, and how can we bring the science together? This program, Future Earth, was created by merging the International Geosphere Biosphere Program, the Human Dimensions Program, and the program Diversitas. Were brought together, not entirely happily by all of them, I'll admit to friends here, but nonetheless, we're working together, and we have already all these existing projects. You may recognize the acronyms. And what I, as the co-chair of the governing council, is saying, what we want you to do, using cities and oceans as examples, is say, okay, we've got coasts, we got IMBER. We've got issues on cities. Let's link these things with the CAN network. So these become the core of the science and working together and finding ways of better working together. Here's some more over here on eco-health, and they relate to the oceans and cities. So we're going to look at let's say, basically a three-dimensional kind of intersection of these projects that we have. These are already going, funded, with great scientists working in them. Let's bring them together in a way that we can optimize the way in which we are able to co-design now and build and produce the science. And as an example, connecting with national programs. There's an international research program called MEOPAR. Does anyone besides me know what that is? Okay, you can tell us. Go ahead.
MEOPAR?
Yeah.
Marine Environmental Observation, Prediction, and Response.
Exactly. I knew you'd know. She's involved in everything like this. Anyway, MEOPAR is a network of centers of excellence led at Dalhousie, Marine Environmental Observations, Prediction, and Response, and I'm part of it. So what I've got is students. One student was looking at how do municipalities in Nova Scotia prepare municipal climate change action plans. What are their priorities? What are the motivating factors? Who do they involve in it? Scientists or just members of their own group, whatever. A second student has been looking at comparing, if I get the arrows right, yes, Maple Ridge, a basically rural community on the Fraser, with Vancouver, also not rural, but a big city on the Fraser River itself. They're both dealing with flooding issues. So he's been looking at issues of institutional response to disaster risk, comparing and contrasting. What are the motivating factors? What are the issues that make one council do different things than other councils, governments, etc.? So I'm just saying we're doing this kind of projects, and I won't go into that further. So just moving right along, I want to talk about just quickly the responsibilities of global science as we see it. As I said, there's Sustainable Development Goal 17 to strengthen the means of implementation, revitalize the global partnership for sustainable development. We as the global science community are working together to try and do that with the UN agencies and hopefully with all the national agencies. We want to make sure that we have capacity in Africa, for example. I chaired a program called START International for 6 or 7 years up until 2015. And we gave out research grants and scholarships in Africa for global environmental change science to encourage the scientists to stay there, not because we didn't want them to come to Canada, but to give the capacity on the ground and also at the same time to network them. Jim Bruce was a member of that committee at the beginning, weren't you, Jim, I think? And John Stone was on it as well, and others in this room. But the idea of the START program, it was a Global Environmental Change START, is to support international science and bring these scientists, give them support to do science, but also connect them with the global research program so they can work together in teams and learn from each other. And I've been to Tanzania and anyway, Mozambique, South Africa, Senegal, and others in Africa and other places. It's very important. We want to build the science and technology. This wizard guy over here I've been just talking to was building space arms and Canadarms and these kind of things. Let's have the technology that help us see our planet as well as the things right on the ground that allow us to build, if nothing else, a better toilet. I mean, I'm not equating Canadarm with a toilet, but, we have to create challenging the responsibilities and provide science to support for social justice. And when I talk about integrated science, people think, well, come on, McBean, you want us to know everything about everything? And I say, no, I don't want you to. I want you to learn to work across the disciplines, interdisciplinary, work globally, international collaboration, but work with society, talk to people. How many people have given a talk to a high school group in the last week, besides me? I said that because I knew I had last week. I spoke to my local high school as I do regularly. But we need to get out as scientists, talk to our business communities, our high schools, our seniors groups, etc. But we also then have to, as I say, bring the excellence in disciplines to work together to address the issues. And we need to address what I call the disincentives. I'm a professor with a PhD in physics. My university can't quite imagine appointing a professor in physics as a professor in social sciences. I am, but it's been a difficulty at times. And I know how many people in this room are fellows of the Royal Society of Canada. Well, it turns out, if you look at it, the Royal Society of Canada, which I admire a lot. I'm very proud and pleased to be a fellow. But I was elected in 1990, I think it was 2 or 3, in the Earth, Ocean, Atmospheric Sciences Division. Then I became a funny bureaucrat as an ADM. Then I became a social scientist. So if my name was put forward now, where would they put me? They can't, because I'm a natural scientist, now social scientist. You don't fit in one of the... We need to think about how do we reward people who can work across the disciplines and bring the excellence together. And the excellence of when I chaired the Earth, Ocean, Atmospheric Sciences division which was the main job, was selecting the fellows. And I'm sitting there thinking, as voices over the telephone would say, well, what is that idiot doing, wasting his time leading a science program? He should be working on that paper for Nature. And if he doesn't have a paper in Nature, out. And I think we have those traditions which are acceptable in a way, but we need to find ways of modifying and working together so that the people who work, Ray Desjardins back there, he's now smiling, he works on agriculture. He and I did our PhD thesis almost at the same time. We studied evaporation by measuring the details of turbulence over, in my case, forests and oceans. He did it over crops and veggies and stuff. But the kind of science he does is so important for agriculture. And we have to recognize that and see these kind of connectivity. So anyway, I'm just saying this is a major issue for us. And so what we're trying to do is build transdisciplinary research, bring it together for a global research program. So as I say, we've got these intersecting issues of cities and energy, economy, transportation, etc., to have effective decision-making for these intersecting agendas of the Paris Sustainable Development Goals, Sendai. We need to have this science, all of this stuff, in some way working with the capacity building, START programs, issues of data, openness, observing networks, satellite programs, in ways that work together so we can bring the integrated science into policy so we can better inform the policymakers on this process, not in science for climate change only, but science that recognizes that important, but deals with, say, some of the SDGs on health, for example, in ways that we can bring it together. And we need to have what I call the co-design of, as these people are getting their data, they need to be willing to work back with the science communities to talk to both groups, the development groups, the science programs, in a way that they work in a proactive way to inform us of the science they think they need and have that continuing debate. And that's the job of CCAR, now that I know what your acronym stands for. And so we need to integrate the national programs, and we need to have in my opinion, a Canadian National Committee for Integrated Science for Agenda 2015-2030 that involves federal, provincial, municipal, private sector, academic, government science, others. So there is some mechanism we have, not a huge bureaucracy, but a meeting place of bringing people together to talk about how, so we address the important issues, we don't leave any gaps, and we don't have any duplication. That's important. So just to say, as been noted earlier, we are merging the International Council for Science with the International Social Science Council. This is one of our illustrious groups. This guy is Sath Cooper from South Africa, who's an interesting character. He had trouble getting into Canada for years because on the visa form it says, "Have you ever been in prison?" And he had to check yes. Do you know what he was in prison for? He was Nelson Mandela's psychological advisor. So he spent 4 or 5 years living with Mandela in South African prisons. He's now the president of the International Union of Psychological Sciences and the vice president of the Social Science Council. Anyway, just say that that's just some of the group we're meeting. We've been working together. There's been agreement in principle in October 2016 to merge. We're now setting up teams of people. And in October 2017, coming up, we will have a vote to yes or no. And I'm confident we will have a vote to merge the two to create one international science organization. And before any of you are allowed to leave the room, you have to give me the name you suggest for a merged International Science Council. I'm just joking a bit. But the idea is to be a global voice for science that speaks and stands for the value and authority of science, from fundamental to stakeholder-engaged science, for its continued advancement throughout the world and for the benefit of all, providing leadership, catalyzing, integrating. And as I say, we hope in 2018, probably in October, we will have the first General Assembly of the new merged organization with the new name that your input is required for, to bring together a global science organization and elect its first president. And I will continue as president of the Council for Science, and Alberto Martinelli from Italy will continue as the president of the Social Science Council until that merge takes place. So my poor wife has to do with me being traveling endlessly for another year. That's beyond what I was originally expecting, but she loves it.
Yeah, sure.
I can't see her. John, there she is. She's still smiling. Okay. I want to end, as I always do, as Don Conway noted. These are grandchildren and somebody's grandchildren, but importantly, these are my grandchildren. That arm, take it out, it's mine, because one of the grandchildren and my wife took the picture. But anyway, here's my daughter and her husband, our grandson, who's now in third year university, our granddaughter, Amanda, is starting at Carleton in cognitive science this September, and Maya and Jade, that's Maya, I think, they're twins, and from pictures I can't tell this far away, are 16-year-old twins. But I say we are building on science. This is Einstein's statue in front of the National Academy of Sciences. And we went there. We take them on a family holiday every year. So a couple of summers ago, this is 2 or 3 summers ago, we went to Washington, and I said, it seemed quite acceptable. So I sit on the statue and we'll take a picture. So traditionally, the idea is here we're going to build on science for the benefit of our children and grandchildren, all of us around the world. And that's what we need to do to address the tsunami of what is happening and make it not embed us all, not just standing there reading nice text. And with that, I thank you for your attention, and let's continue to work together. Thank you.